Welcome to 52 Weeks of Stats, and this week we're going to cover why natural language processing is a challenge for statisticians. This video is not going to cover every single challenge that natural language processing poses for statisticians. It cannot. The reason is because no matter how many reasons or challenges I list, the internet always wins, which I really do congratulate the internet for doing so for so many years. What I really want to cover in this video are the challenges I've seen, the challenges I've come across, and some of the research I've seen that other statisticians come across in this day and age. And also I'm just trying to gather my thoughts and put them down together for just the general public to understand why this is a challenge for us. As always, this video is for non-statisticians and statisticians alike. So if you're thinking about going into statistics or going into computers, well, not computer science for this video, but going into statistics or something probabilistic, or maybe just somebody from the general just trying to understand a little bit more about natural language processing and why it can be difficult, this video is for you. Probably not for an expert who's been doing this for years, although I do think that you might be able to get something from it if you watch it through. Before we go into the video, this week's video is going to be a little different because this time I'm going to be using slides. So in some discussions, just to help the audience or you go through this, I will put up some slides. You just hear me talk for a little while and I'll try to come back to myself. This is the first time I'm doing this, so there might be some imperfections and some cut mistakes. However, as time goes on, I will try to get better at this. The first thing I want to discuss is what is natural language? What is a natural language? You can always go on Wikipedia or some dictionary out there or the internet to find out what a natural language is. But to me, this is what a natural language is. A natural language is genuine to how you speak, right? It's genuine to you, based on you are as a person, how you identify yourself, the pronouns that you use to identify yourself, the ethnicity that you use to identify yourself. That is your natural language. This is not based on your location. So your location does not determine what your natural language is. And it's different for everyone. In addition to all this, a natural language does not have to be spoken per se, right? Sign language is a natural language for the deaf, right? That is how they naturally emote, show what their thoughts are. So there are different types of natural languages. So what is natural language processing? Well, natural language processing is the ability for a machine to understand you, regardless of how you communicate. And here I'm saying machine, not just computers. So a good example or a small example will be a car, which is a mix of what machine and computers in there. By the way, computers are a subset of machines, just so we know. But when you get into a car, when you place your hand on the steering wheel and you move the steering wheel, you turn the steering wheel left or right, you're sending an input to the machine how you naturally communicate with it. And you expect that machine, right, to understand what you're saying and do exactly as you say. So that is a type of natural language process. That's how you're communicating with that machine. Most of us think of natural language processing, in this case, as speech or text that we've given a computer or a machine to process it to find some meaning in what all that is. That is a large part of natural language processing. What I don't want to do in this video is just limit natural language processing to just voice or text. Movements also are a natural language that you do expect a machine to understand if you're interacting with the machine that way. So why is natural language processing important? What's the big deal? Well, I'm going to list 3 reasons over here, but as I always say, the internet always wins. So the first 2 reasons are what I can think of today, and the third reason is more of what the future holds that I cannot see yet, or what someone out there knows that I do not know yet. So that's filled in for the third for that one. Also, within this video or whatever comments there may be wherever this is put in the future, just write some comments on there as to what some of the uses that that NLP or natural language processing can be used for. The first reason why natural language processing is important is for command recognition. We as human beings give commands all the time. When we turn a machine on, we're given a command. When we ask it to be turned on, we're given a command. When we ask for the weather, whatever it is, we're always given commands. So command recognition is one of the most important reasons why natural language processing is important. The second reason why natural language processing is very important within this command recognition part is intelligent querying. So what do I mean by that? Right now, we gather data from so many sources. The amount of data we have just grows every single day. So what other professions would like to do is to be able to query this data, go through this entire thing, search through this entire data without understanding the programming language to do so. So that's where intelligent querying will come in. When you ask about the mass of an object, what is the definition of mass? To go through the headache of actually programming the definition of mass to a database to get the information that you need is way too much. Sometimes intelligent query can also mean semantically understanding what you're trying to say, right? Abdomen, stomach, even though they're just synonyms of each other. And I know semantics goes way further than that, but sometimes semantically you mean something else, right? Or well, you mean something else or something similar to what you're trying to say. So instead of putting in every single permutation of what you're trying to query, intelligent querying can help you get there. The third one is diction. I have a personal diary that usually whenever I try to use diction towards it, always have to end it with a period, comma, full stop. Well, if we can, if command recognition, which is sort of what diction can be, right, is at where it needs to be, then I can simply just pause or stop at the end of the sentence, and the machine should automatically know that I mean a full stop or a period. Or if there's an inflection in my voice, do I mean does it mean that I need an exclamation point there, or is it a question mark? The second is processing of text, right? Which is what most people would know natural language processing as more like today. However, we're talking about processing of text, not just, for sentimental analysis or whatever we're trying to do out there. Those are kind of solved. We're talking about, how do you process open-ended text? So an example that you see on the slide right now is, how did you feel after taking this medicine? Now, if you have medicine A created by your company and you feel great about it, let's say 5 billion people took this medicine and let's say 3 billion of them had a response. There's no way you have all the possible time in the world to read through all their responses. So what would you like to do? You would like to take all your responses, process all that text, and then go back to see what sentiments are positive or negative, right? And then from there, you want to say, okay, fine. Of all the negative responses, which ones are super negative? What do they have to say? Was there an adverse effect in there that wouldn't catch in time, right? Because you possibly couldn't have the time to read 3 billion responses, a machine can go through that very, very quickly with the right programming, sort them out for you so you can focus on which text that you want to look at. The third reason here is what I call everything else. Again, because I salute the internet for its ability to never be wrong, right? So what does this mean? I mean, Star Trek's Universal Translator. You walk in, Klingon is speaking to you, he's speaking Klingon, you're speaking English. Guess what? The translator automatically translates everything and voila, you can understand each other. Semantically too, right? So that's one of the uses that it can be used for, just general translation. The other one is, well, I don't have any. I just know that there are many, many, many uses for why natural language processing is important. Yes, research in your own language. So if you're trying to do research or you're trying to find something out in your own local area, however you've documented the way you speak, the way you express yourself, well, natural language processing can help you translate what you've done to maybe another language for somebody else who is trying to find maybe something similar or the same thing or something tangent to it. It's going to be completely wrong to say, well, in order to do any kind of meaningful research, all research have to be done in English. I mean, fuck is that, right? Well, what is that, right? So that's also another use that could be used in the future. But then again, I salute the internet, and please let me know with your comments down below. Next, I'm going to discuss natural language processing factors. Before we go into this, I just want to give you a few things. There are 9 factors that I've sort of come up with on my own. And the first one is has the largest bandwidth, right? And the second one is a subset of the first one. The third one is a subset of the second one, and it goes on and on and on and on. And I've tried to, just sort of put it together in which I feel like the 9th one is the lowest level of a processing factor that statisticians have to deal with. The other thing that I want to say with this one is that we don't have to deal with all these issues all the time whenever we're processing natural language. This is just, imagining if we had to start natural language processing from the very, very, very beginning. Here are some of the things that would have to tackle. So, subsets of each other, right? And again, my thoughts. Feel free to please completely disagree with what I'm trying to put out here. I actually do welcome you disagreeing with what I'm saying, because I'd love to see your take of it too. So the first factor in natural language processing is time. Time changes how language is understood. Period. English 300 years ago is not the same thing as English now. We all know that. Any language, any number of 100 years ago is not the same as now. Also, with time, certain languages don't exist. So if you have to process a natural language, whether it's voice or text, and you don't know what time period it's coming from, that can be a headache. That can be a headache, because choosing the wrong time period can completely change the complete meaning of what the person or what the text is trying to say. The second processing factor is language detection. Language detection is a tough problem to solve. It just is. All right. So whenever you get text and you don't know which language you're going to be getting, right, or the audience didn't tell you which language they're going to be speaking for any reason, well, language detection is going to change how you understand the text that is coming to you, or the voice that is coming to you, right? So I don't think I have to go too crazy into language detection, but language detection has been a pain for statisticians for a long time, and computer scientists who have to work along with us, or for the unlucky statisticians and computer science combinations, right? So language detection it's just a challenge. So from first detecting the time period that the voice or text could be coming from, to saying, okay, fine, this is coming from, maybe the 2000s, to detecting which language they speak, yeah. The third factor that I've come across is dialect. After you've detected the language, you need to detect the dialect. The dialect is the shortest distance from any language, by definition, right? However, how do you detect dialect? Do you do it based on geographical area? What are the syntax that you look for? Where does a language end and a dialect begins? And remember, the proper version of any language is a dialect of that language. So if you start with natural language processing, and my favorite is Arabic. I don't know Arabic that well, but I do know that Iranians who speak Arabic versus those in Morocco sometimes do not understand each other, because I have friends from those regions. The same thing is with Yoruba and Ijebu. Just so many dialects out there. My whole point is that detecting a dialect from a language, once you've confidently said what language it is, can be a little bit difficult. Sometimes you will have dialects that mix two languages together. So Spanglish. So how do you detect Spanglish to begin with, right? Does your language model detect English and Spanish and pass those with high confidence. So now your dialect detection is forced to say, oh, well, this is Spanglish? I don't know. My point is dialect detection, tough. The fourth factor in natural language processing, what makes it a challenge, are accents. Heavy accents can skew how a word is said for a machine to not be able to understand it. And we're not talking about accents in just understanding a voice command. Sometimes you want to take something somebody else said and translate it to text. So if you've ever seen subtitles, that's one example of it. However, as heavy accents can skew the spelling of a word. So I don't want to go too deeply into it because I do believe that everyone in the world has an accent. I really do believe there is no such person who does not have an accent. Now, the accent you may have may be spoken by a larger group of people, or within your people, you do not have an accent. However, once you get out of that small little geographical area, you have an accent to everybody else. So that is one. Anyway, I don't want to kill the whole accents thing, but yes, accents can be a challenge, not only in understanding, but also in translating what you're trying to say. We are down to my favorite, vernacular. Vernacular. Ebonics is an example of a vernacular, right? Vernaculars are usually expressive, right? They're local, they're geographic, right? Vernacular is the reason why, no matter where I go in the world, I just don't fit there sometimes because I don't speak the same way they do, right? I don't understand the idioms of that vernacular, right? I don't understand the negations of that vernacular. So let me give you a good example with negations. Ain't no sunshine when she's gone. If you take that sentence and you throw it into a truth table, you're certainly going to be wrong as to what Bill is trying to say here, right? There's a certain vernacular. How certain vernaculars negate is unique to them, right? How they express. In certain vernaculars, certain parts of speech are left out. So, one that is very common in Brooklyn is, he gonna learn. What happened? The verb to be is taken out. It's implied in there. And there are many vernaculars in which certain parts of speeches, especially some pronouns, well, it doesn't really matter the part of speech, it's endemic to that area. So when those parts of speeches are taken out, it's very hard for a machine to fill those in if it's not familiar with that vernacular. Then we get to colloquialisms, which I never pronounce well for whatever reasons. Colloquialisms. My favorite thing about colloquialisms is that maybe one day when I become a parent, I'm not going to understand what my kids are trying to say, even though I might understand the vernacular, right? It's more informal, right? It's just way more informal. There's some profanity in colloquialisms, but not all the time. But usually the profanity is something positive, right? That you as the parent or the adult, these are just quotes over there, can't really relate. So colloquialisms are more of the younger generation as they go on. Colloquialism is not something that you would sort of like use in an interview. But what happens as time moves along is that a colloquialism goes from this, they like quote unquote, this use over here, that it becomes a vernacular. And if it's used long enough, it becomes a dialect. Or it becomes part of a dialect, a permanent part of a dialect. So colloquialisms are, even though they're informal, and I like to call them informal, however, they can become more formal as time goes along. Maybe not the profanity part of it, but yes, there is. I don't want to go through examples, but there are songs that you listen to in which people go, oh, why are you using that word? Well, it could have begun as a colloquialism, and now it's a vernacular. And now it's part of a dialect because it's been used almost the same way as time has gone on. Sometimes colloquialisms are used to take the insults out of a word, right? And when they used to take an insult out of a word, again, they start off informally to take like the pain out of the word. So you're gonna call me a what? Okay, fine. So it's used to take it, and then as time goes on backwards, and that word is used the entire time, then it grows, it grows, it grows. I'm not going to use any of the examples that you might be thinking of today, but another one that we use in Accra, Ghana is chalewate. Okay, chalewate are literally nothing but slippers. But chalewate means, my friend, let's go. Okay, not a painful word or anything like that. However, it's colloquial that you use the word that the word for slippers literally translates to my friend, let's go. Chalewate. So now, this is back in 1992. So if we're not calling them chalewates in Accra anymore, please, I choose peace, right? I've been in the United States for quite a little bit of time, but I choose peace. However, what I'm just trying to say is that it starts off something being colloquial, is now part of a vernacular, and now there's an entire dialect in Accra, Ghana that, use the word chalewate all the time. And then there was inflection, the stress on vowels. Stressing a vowel can change the meaning of the word all the time. I'll try to give a few examples today. The most common example that I can think of is resume and resume. Pretty huge differences, right? One is a noun, the other is a verb. Well, another one is, let's just, like in Yoruba, okay? Which is a Nigerian language. If you stress the wrong vowels, you mean something completely new. And they have more vowels than I can think of, right? I think it's a, e, o, u. Or better yet, ba, re, ti, ku, o, mi, yo. To all the Nigerians who understand this, again, I choose peace. There's no need to translate it. My point is, vowels can change the meaning of a word, right? And Yoruba is one of the is the most notorious language that I know that does this very, very well, right? Or very, very often. It can also change the subject of a sentence, right? I don't know who did it. Okay? Implying that you don't know who did it. It doesn't imply any, it just says, I don't know who did it. But if you look someone straight in the face and say, I don't know who did it. In that sentence, the stress on the I can imply that you don't know who did it, but you might know someone who knows who did it. Right? So when a computer is trying to reason, right, that inflection can mean something completely different. So inflections can change a sentence drastically. And just trying to understand that from a statistical point of view is a headache. Sometimes inflections comes in a sentence where you put an exclamation point at the end. Well, what is the exclamation point inflecting? Is it inflecting the beginning of the sentence, the middle of the sentence, or the end of the sentence? But the exclamation point is exactly where it needs to be. So inflections does change the meaning of a sentence, and it can be a challenge for statisticians too. The last two are, I would say, my least favorite because I always get these wrong, right? No matter what group I'm in, I always get them wrong. So slang. Every group has their own slang. There's an insider slang. Doctors have their own slangs. Lawyers have their own slangs. MBA students who just want to punish the entire world because they feel like they're cool come up with slangs for an entire industry that you go, are you serious? We're calling this now this? Sure. They do that all the time. slangs change all the time, right? And sometimes some local object and so some local activities can add to a slang. So if there's something that happens very, very locally, I'm sure that the slangs in Antarctica are not the same as the slang in someone around the equator. Given they don't have the same weather a good number of times of the year together. So slangs are very, very, very localized. Um, Slangs can sometimes become formal as time goes along, right? So can you give me the ABC report from the XYZ blah blah blah? Or slangs can also mean that somebody takes abbreviations and makes them slangs, right? So and again, not actually, I will pick on MBA students because you do this all the time. However, something that has a very, very long name to it, it becomes an acronym, and then from acronyms, then the acronym is just used as a slang in the industry the entire time, to the point where nobody knows what the formal word for it is anymore. And then you get on an interview and somebody asks you if you know about the acronym, and you're like, what are you talking about here? But they forgot that they're using a slang or a jargon in their case, right? So slangs are also, if a slang is very hard for a human being to understand who's not from the area, imagine what a machine is going through. Well, when machines can feel, right? It's just confused. It doesn't know. And your acronym can stand for so many things. Every group has their own, whether it's a local area in some small city somewhere else, or it's a profession in which, well, this is just the way we talk. And the last one is lingo. There's not much to say about lingo. Just very, very, it's the lowest level. According to me, at least, right? It's the lowest level of, something that you do need to detect. There are top 10s every single year. Like that shit was fire. All right, that is a lingo, right? It just changes so quickly that I really hope that as I get older, someone gives me a top 10 list of lingos that I use in my local area, so I sound cool, right? Because I just can't do it. I try, I really can't do it. The only way I understand new lingos is to quite literally listen to music let's put it this way. I like my old music. I love soul music. I love music from the 90s, I like my Angie Stone. I like my Jill Scott. I'm not sure what kids call R&B nowadays, but it's not my taste. However, I do have to listen to that sometimes to understand what the new lingo is, and then I'm out here just searching the web for what wings and pizza means. My point is, lingo is difficult on the old, but remember that it's also a little bit more difficult on just machines who are trained on the old. So have a little mercy on us, will ya? So the factors that I just mentioned are not all encompassing. I mean, you can come up with your own too. You can rearrange the order. You can do whatever you want to do with them. But these are Tokumbo's thoughts. These are just my thoughts on why natural language processing is a huge challenge in the industry. And as time goes on, it is going to be hopefully it's solved, and not solved completely, but because it changes all the time, hopefully we come out to different ways of solving it, or better ways of solving it. But all I'm just trying to say is that it doesn't make the job any easier for us. This is why you look at your phone and you start screaming at it, or your phone decides to call your first ex-husband while you're on your third husband, or it calls your first girlfriend from college while you're married with 4 kids now, because guess what? It confused the sounds of the word, right? It happens. It doesn't mean you should forgive the machine. It just means that it'd be really nice if you understood where the machine is coming from too. Cool. So, how do models usually work? Okay, this is not how every model works, but how do models usually work? there's no one model or there's no one formula that can determine all these things that I just spoke of. Sorry about that. It's almost impossible to. There's no one formula. So what do? You build a model or a formula, for those of you not familiar with this line of work, that only detects, let's say, language. And it's very confident in what language it's chosen, it detects. Then it passes it to the model that detects a dialect. Then it passes it all the way down. So there are multiple models working together trying to get to a final prediction, right? So just think about, a model looking at a piece of data, determine what it thinks it sees, right? Passing the parameter to another model. Just imagine that as playing the game of telephone. At the end, it can be very wrong, right? Unless you're just adept at playing that game of telephone. So looking at the time model, and I'm not saying that every model goes through this. This is not every single natural language processing project. However, I'm just trying to give you, like an overview of it. Imagine the time model detecting the time, right? Sometimes you don't have to detect the time. You can literally ask. Or, if you get a form from someone which someone has filled out, you can literally look at the date and say, okay, fine, I can assume that this is around the time of that date. And then move on from there. So you don't need a model from there. Or the same thing is with language, right? If somebody fills out the form, you can have them choose a language in which they're going to fill out the form to tell you something, right? So some of these do not have to be models. The headache comes in when you have to detect them when it's not told to you. And this is where speech recognition becomes a headache. By the time you take it from analog to digital, and then make sure that you probabilistically find exactly which word they're trying to say with your hidden Markov models, whatever. My point is, yeah, you will make some mistakes as time goes along, right? And as you get to more of the highly localized, models that you would call, or the factors that the highly localized factors, right? Sometimes you have help there. Sometimes you do. In life sciences, we have ontologies. There's SNOMED, there's MEDRA, there's RxNorm. You have ontologies to help you out. There's a knowledge graph to help you out. Some industries do not have ontologies at all, right? But some industries naturally have an ontology that comes with them. For example, chemistry. Right? Most of chemistry can be built with an ontology. Well, I'm not a chemist, so please, don't yell at me. I'm just a statistician. But I'm just trying to say, hey, maybe we can work together to build an ontology for chemistry, for physics, for biology, right? So we can understand, okay, when somebody says cell wall, right, they don't mean a prison cell wall. They actually mean a cell wall, right? Abdominal, stomach, right? What are the synonyms out there? So I'm sure that these can happen, but these more localized factors can easily help you identify an outsider. So, what are my final thoughts here? Hopefully by the end of this, and if you've lasted this long in the video, you've seen that natural language processing is not a small challenge. We are all trying to communicate. And the difference between all of us communicating is the intensity in which we communicate. But most of us are trying to communicate the same thing at one time or another. That is one. Natural language processing can help us research and develop in our own natural language without compromising who we are. And I don't mean like hardcore, mathematical or statistical research in a lab with a couple of, no, that's not what I mean. If your grandmother took medicine and she feels a certain way after taking that medicine, the last thing you want to say to your grandmother is, look, for the doctor to understand us, you'd have to speak English. Yeah, that is so wrong, right? That is completely wrong. You want the person, especially if the drug is on trial, to be able to communicate in their own natural language, so we can all get to a more perfect union. Yeah, I know. Whatever. But yeah, that's what we're looking for. Our natural language also helps us maintain our individuality. This is why it's so important, right? And it's everyone's problem. The fact that Google is working on natural language or Amazon is working on natural language processing does not mean that, a language that might be lost in some part of the world does not need to be worked on with natural language processing. We need your help there too if you understand that language. Actually, that's where we really need your help. So this is everyone's problem. Now, what you could do in that remote part of the world in which there's a certain language endemic to a small society is that there are lots of tools out here and there are lots of software to help you get started. But the software is not going to do what you can do. Your understanding of it. So yeah, it's everyone's problem, and I hope you join in the fight. I hope you join in the fight to helping us all communicate a little better. Anyway, I'm shooting this video on my 36th birthday, and I couldn't be any happier with what I've chosen to do with my life. So as I'm sitting here, it's COVID out, it's snowing, and there's really not much I can do besides sit here and talk on a video to you. I just want you to feel what I feel today. Live passionately and do what you love to do. Thank you.